Today we're going to talk about mapping figures using transformations. And just want to remind you before we get started on these notes that we've been working with three types of rigid motions. We talked about translations. And translations, I put in parentheses slides when we did our notes earlier. And sliding means that we're moving the picture right, left, up, and down somehow. And then we talked about reflections, where we had some line of reflection, possibly the x-axis or the y-axis or the line y equals x, and we wrote our figure on the other side, flipped. And that's what we said in parentheses on our earlier notes. We said reflections are flipped. And then the third type of rigid motion are our rotations, where we're turning them somehow. Oftentimes 90 degrees counterclockwise, 180 degrees counterclockwise, or 270 degrees counterclockwise. And what we're going to be given today, at least for starting, is we're going to be given the picture here, and we have to identify what transformation is happening. So we've got figure STUVW. It is transformed to produce the image S prime, T prime, U prime, V prime, W prime. And we want to identify the transformation that was performed, and we want to write the rule for the transformation. And just as an aside, the OST likes to ask these questions. So this is a popular OST item. If you're keeping some sort of note in your notebook about that, this is one that you could probably start. But down here, kind of to the bottom right, is our original polygon, and then up here is our moved one. We've got the U prime, the T prime, and so forth. The nice thing about this one is, it looks like the only thing that's changed here is the location. We haven't turned it. We haven't flipped the figure. We've only moved it from one place to another. And that type of rigid motion is called a translation. And once we know what the rigid motion is, what the type of transformation is, let's look and see what happens here. If we start at point U here, to get to U prime, we went 1, 2, 3 spaces left, and 1, 2, 3, 4 spaces up. So over here, you might write 3 left and 4 up. But on the OST test, in terms of the rule, they're going to want us to write it in the appropriate form, which is an ordered pair, x comma y, and then we have the arrow. Remember that that's the maps to, and then we're going to put it in the proper format. Well, we're moving 3 spaces left. That's going to be x minus 3. And we're moving 4 spaces up, so this is going to be y plus 4. Again, 3 types of rigid motion. We just saw figure KLMN is transformed to create image K prime, L prime, M prime, N prime. Identify the transformation that was performed and write the rule for the transformation. So again, we just saw a translation where we just moved the picture from one place to another. But if we take a closer look at this one, starting up here at L, what I notice is that L is up here on top and K is up here on top. But when we compare it down here to our figure kind of below the x-axis, our L is down here on bottom and our K is down here on bottom. And what we did is, it looks like we've flipped our graph over. And the flipping, in terms of the transformation, that's called a reflection. And in terms of the rule, what we write is just a reflection over the line, and we need to know what is that line. So we've got to look and find this. We think that it's a horizontal line because we're flipping it this direction. I know you can't see that on the video, but we flipped it so that L and K, which were pointing up at one point, are now pointing down. So we're flipping it some horizontal distance. And one of the things that you can do is we can count the values between M, the two M values. Well, we've got 1, 2, 3, 4, 5, 6. We've got a distance of 6. And since we're reflecting here, we need to go halfway between 6, which is at 3. And let's just check it here. We know the M's work. 1, 2, 3. 1, 2, 3. Well, let's try the L's. 1, 2, 3, 4, 5. Let me actually show it on the video. 1, 2, 3, 4, 5. And coming from the L down here. 1, 2, 3, 4, 5. So now we need to identify this line. That horizontal line is going to be y equals 3. A suggestion, if you get mixed up with which one's vertical and which one's horizontal, look at it, type it in on Desmos. See what it looks like. Does it look like that? Or did you go the wrong direction? A good way to check. Number 3. Which of the following sequence of transformations would map ABCD onto EHGF? So first of all, if you look at the first two examples that I gave you, we had STUVW, and then we had S prime, T prime, U prime, V prime, W prime. We had the same letters on those first two examples. Now we don't have the same letters. But in this particular example, which, by the way, is a multiple choice question, so I'm just going to mark that on there if you're confused about that. We're going to be picking one of the answers. But before we do, I need to tell you that A is going to map to E. B maps to H. C maps to G. D maps to F. The letters have to be in the same place. So again, A is the first position, E is the first position. So A goes to E this time. F is in the last position, D is in the last position, F is in the last position. Look at where they are listed, because that's what goes with one another. So the first thing that we're going to look at is, we're going to look at a rotation of 180 degrees clockwise about the origin, followed by the translation of right 8 up 2. And the tricky thing about the OST is they can make one of these points work and another point not work. So you have to try more than one, but start with one. Do you have any particular A, B, C, D that you would like to start with?
A.
Okay. So if we start with A, that point is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So A is actually negative 8, negative 4, and I want to check one more time. Yes. If we're going to do a rotation of 180 degrees clockwise, the nice part about 180 degrees clockwise is it's the same rule as 180 counterclockwise. Ultimately what happens is there's no flip, and we're going to change both signs. So this is going to become 8, and negative 4 is going to become 4. So over here in the graph, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Now remember, there's more to it. We did the rotation of 180 degrees clockwise. And now what it says is we're going to follow that by a translation of right 8 up 2. Well, we don't even have 8 spaces to the right on our graph. And what we're wanting is we want A to end up at point E. Is A going to end up at point E? No. Let's try B. A reflection over the x-axis followed by a reflection over the y-axis. And why not stick with point A? If we reflect that over the x-axis, we've got 1, 2, 3, 4 spaces away. So on the other side, 1, 2, 3, 4 spaces away is going to be our new A. That's the first thing that happens. So here's our A. And then it says followed by a reflection over the y-axis. Well, this pinkish purple point is 1, 2, 3, 4, 5, 6, 7, 8 spaces away from the y-axis. So on the other side, 1, 2, 3, 4, 5, 6, 7, 8 spaces away from the y-axis. Lands about there. Is this graph a reflection over the x-axis and a reflection over the y-axis? We need A to end up at E. Does A end up at E? No. So it's not B. So let's look at another value here. Letter C. Reflection over the x-axis. Well, luckily enough, we had a reflection over the x-axis last time. So we can still look at this point here. And now what it says followed by a translation of right 10 up 2. So we have to count from that pinkish purple point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up 2. Did A map to E? Yes. Keep in mind that the OST is tricky sometimes. You can't just find one value and go, oh, I'm right. We've got to just test a couple more. If we look at letter C here, C is, let's do B. B is 1 space away from the x-axis. So here's 1 space away from the x-axis on the other side. Because it says, on the letter C, it says a reflection over the x-axis. So now we reflected it, and then let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 2. B maps to H, and notice here, B should map to H. Try one more just to make sure. Again, we can look at letter C, which is 1 space away from the y-axis. So on the other side, 1 space away, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 2, C maps to G, and now we're pretty sure that C is the answer. The problem with these problems is they take a little bit of time. If you're really going to get them right, they take a little bit of time. And as we turn this over, it's going to take even more time. Which of the following transformations would map onto figure A, B, C, D, E, F onto figure A prime, B prime, C prime, D prime, E prime, F prime? Select all that apply. We need to work out all of them. But what we just did when the video wasn't on is we figured out that the reflection across the y-axis isn't going to work for us. Our figure on the lower left side doesn't flip over and land on the lower right side. So now we're on letter B. A translation left 6 units. If we start with A, 1, 2, 3, 4, 5, 6. And I went the wrong direction. But I should say that I really wanted this to be a right 6. So I'll try that one more time. We're going to go from here. 1, 2, 3, 4, 5, 6. Lands on A. But remember, the OST can be tricky. If we start at F, 1, 2, 3, 4, 5, 6, we land. If we try E, 1, 2, 3, 4, 5, 6, we land right where we want to. So for those of you who are still with us, fix that, make that right on your notes. And that is one of the answers. But once again, because it's select all that apply, we can't just find one answer and move on to the next. We need to find all of the answers. So letter C says a rotation of 180 degrees about the origin, followed by a reflection over the x-axis. Again, if you have a good eraser, I would erase that picture. And then when we go back and look at this, let's pick point A again. The point A is, and I've got to look at the right figure here, but point A, this figure, is our original figure. It is 1, 2, 3, 4, -2. And what part C says, we can start with 1, because if it doesn't work on this one, then we can move on to our next choice. We don't need to do all 5 or 6 of those points. But a rotation of 180 degrees about the origin. And the thing is, it doesn't have to say the rotation of 180 degrees about the origin. It doesn't matter if it's clockwise or counterclockwise. We still get the same value. So as we look at this point here, and we do the 180 degrees rotation, this is going to be no flip, but change those signs. So 4, -2 is going to become -4, 2. And it might have been nice if I wrote down the right point, first of all, which is, it should have been -4, -2. So now that makes that +4, +2, +4, +2. So there's the new A, because that's our first rigid motion that we work with. We need to go in order. And now we're going to reflect that over the x-axis. Well, if we flip this over the x-axis, this point is 1, 2 spaces away. On the other side, it would be 1, 2 spaces away. Does our A land where we want it to land?
No.
No. So we only have to do 1 point, and that one doesn't work. But again, because this is select all that apply, we have to keep working through these. So our next value, and again I'm going to erase, is a reflection over x equals -2. So our line x equals -2 is going to be this line here. And remember, let's pick a value, and I'm going to pick A. So A is here. It's 2 spaces away from our green dotted line. On the other side, 2 spaces away from our green dotted line. It's going to be here. That's our first part. And now it says there's going to be a reflection over x equals 1. Well, x equals 1 is here. And this green point is 1 space away from the purple-pink line, and 1 space away from that purple-pink line. Ends up to be here. Exactly where we want it to. So let's test another. And realistically, we should probably do 2 or 3 points. But we're optimistic that this is going to work for us. So let's go and look at point B. Point B, if I could actually get it graphed here, has a value 1, 2, -3, 1, 2, -3. -3, -3. And again, what it says is, it says a reflection over x equals -2. So we're going to flip it over that green line. This purplish pink point is one space away, so on the other side, one space away. Well, now that purple pink point is two spaces away from the purple pink line. So on the other side, two spaces away, lands right here. And that second one works. Now technically, we should do a third, but we've done two, and we're running a little short on time. It is letter D. The thing is, not only we've got those two, but it doesn't matter. All five of these could be answers. They're not, but letter E could be an answer as well. So what has to happen here is we've got to check one more time. A reflection over the x-axis. So I'm going to erase here. And a reflection over the x-axis with point A. Well, it's two spaces away, so two spaces away. There. And then it says a rotation of 180 degrees about the origin. Well, this is 1, 2, 3, negative 4, 2. So if we rotate that, no flip, change both signs, we get 4, negative 2. And 1, 2, 3, 4, negative 2 doesn't land where we want it to. Which of the following transformations would map figure PQRS onto figure P prime Q prime R prime S prime? Select all that apply. So remember, again, all of these could be an answer. One of them could be an answer, or two of them, or three of them. Just when it says select all that apply, we have to check every single answer on here to determine which one it's going to be. Hopefully there's at least one of these that we can visually look at and go, oh, that's not the answer. But as we take a look at our first one, it says a rotation of 180 degrees clockwise about the origin. Well, let's just start with one of the points of P. And P has an order pair of negative 2, negative 2. And when we're rotating it 180 degrees clockwise, that's no flip, change both sides. So when we get 2, 2. So when we come over here and look at this, we go 2, 2, and sure enough, that's a point. So we're starting off good there, but the OST is tricky sometimes, and it might try to trick you, so we have to check a couple more points. If we check S, S is negative 3, negative 4. So again, 180 means that we're going to change the signs. So it's going to be 3, 4. When we check that, 3, 4 is here. So we're 2 for 2. And we should probably try one more. And let's try Q here. And Q is 1, negative 2. 180 degrees clockwise, and we're going to flip both sides. So it's going to be negative 1, 2, and we're not flipping anything, we're changing the signs. So negative 1, 2 is here. So we definitely can say that this is a rotation of 180 degrees clockwise about the origin. The other thing here is that if you have a good eraser, sometimes this gets lost, and so if you can erase it, it's helpful because it gets jumbled up quick. But if we look at letter B here, it says a reflection over the x-axis. Well, if I start with point Q here, start with point Q. Point Q is 1, 2 spaces away from the x-axis. So on the other side of this would have to be a point of Q in that pinkish purple color, and there isn't. That problem Or letter B is probably one of those that you could visualize and you might not have to do any work with. But again, a good eraser. If we stick with letter P here, and letter P, and it says translation of 1 unit right and up 4 units. Well, this was P. And even though I covered it up there, that is a Q prime. So P does land where Q is, but it's not P. It needs to be P prime there. So the nice thing is now we can eliminate that choice, but we still have to go through all 5 of them, because who knows how many the OST has selected. So again, I'll erase, and we've got the reflection over the y-axis, followed by a reflection over the x-axis. We're looking down here at the bottom part of the graph. So reflection over the x-axis, P is 1, 2 spaces away from the x-axis, so 1, 2 spaces away from the x-axis. That would be a new P. Q is 1 space away from the x-axis, so 1 space on the other side is going to be Q. I'm going to get rid of this point right there. So that would be our Q. S is 1, 2, 3 spaces away from the y-axis. So on the other side, 1, 2, 3. And R is 2 spaces away, so 2 spaces away on the other side of the y-axis. So there are our points, and let me make sure that I label. Here's the S and there's the R. Because now what we have to do is we have to reflect that over the x-axis. We did the y-axis first. Now we're going to reflect over. Well, Q, our green Q, is 2 spaces away from the x-axis. And then when we reflect it over, we land here. Our P is 2 spaces away from the x-axis. Well, when we flip it over, we land there. Our R is 1, 2, 3, 4 spaces away. 1, 2, 3, 4 spaces away. And hopefully our S works, because the rest of them have 1, 2, 3, 4 spaces away. 1, 2, 3, 4 spaces away. So letter D does work. Again, need to erase to finish on here. We need to check E. And it says a translation of 1 unit right. So let's just do point P here to start. Translation of 1 unit right, followed, so that's going to move our P to that red point right there, followed by a reflection over the x-axis. Well, our red point now is 2 spaces away from the x-axis, so 2 spaces away from our x-axis on the other side, that point would land right there. And again, that point here is a Q. And we're looking at point P as the one that we were dealing with. So our answer is just going to be A and D in this case. Complete the statement below to show that triangle JQB maps onto triangle EWT. Just a reminder that J and E are both in the first spot listed, so they're going to map onto each other. Q and W are going to map onto each other, and V and T are going to map onto each other. So the first thing that I noticed with regard to the J, just looking at the J and the E, is that these are both pointing up. So the same orientation there, and I would like to keep that way. So if we look at this, it says map triangle JQB onto triangle EWT by a reflection across. Well, we could reflect this across the y-axis. Because as we look ahead, it says followed by translation. Translation is a slide. We're going to move it up, down, right, or left. So, but we want to slide that J up to where that E is eventually, and hopefully that'll work for our other two. So what we're going to do is we're going to reflect this black triangle over the y-axis. So J is 2 spaces away from the y-axis, so on the other side, 2 spaces away. There's our new J. Q is 1 space away from the y-axis, so 1 space away. Here comes our Q. And V is 1, 2, 3, 4, 5 spaces away. So on the other side, 1, 2, 3, 4, 5 spaces away is our V. And what we just did is we reflected that across the y-axis. And now what we want to do is we want to get this triangle to land, the red triangle to land on the blue triangle. And let's look specifically at point J here. How are we going to get J from here up to E? Again, because J maps on to E. Well, we go 1, 2, 3, 4, 5 up. So I'm going to write that down. Up 5 units. But let's check it. Does it work for the W, which is mapped from the Q? 1, 2, 3, 4, 5. Yes. Q maps up. 1, 2, 3, 4, 5. Yes. V goes up to T.